All right, so we're going to go over a couple of questions from the review. And so we start off with number 6 here. So these are kind of challenging because it's like it has the one with the 1, 2, 3, 1 and 3 only, that kind of sort of thing. So I just want to go through that and kind of talk through how I would do this. So for the function above, which of the following would be the reasons why function g of x, which is that piecewise defined function, is not continuous at x equals 3? So what you want to notice is that for values less than 3, it has sine of x pi over 4, and then when x is 3, we have the square root, or x times the square root of 2, which really is just going to be 3 times the square root of 2, but so it should be like a const, just a point there. And then for values that are greater than 3, we would have 3 or x times the square root of 2 divided by 4 times x over 6. So g of 3 is undefined. Well, if I plug in 3 for x in this function or in this piece here, that's going to be defined. So that doesn't work. So this one is not right. Then the limit as g of x does not exist as x approaches 3. So as x approaches 3, I need to make sure that that the left and the right are going to be approaching the same number. So I need to make sure that the limit as x approaches 3, basically from the left, which is going to be in this function here, so that's going to be of x pi over 4, which is basically going to, sine of that. Sorry about that. And then, so that's going to be the sine of 3 pi over 4, which is going to be the square root of 2 over 2. So that is where the limit of g of x is. And so then I would just need to make sure that as x approaches 3 from the right, so I'm going to plug in 3 to this function, so that'd be 3 from from the right. So this would be the limit as x approaches 3 from the right of x square root of 2 over 4x minus 6. So this is going to be 3 square root of 2 over 4 times 3 minus 6. So it's 12 minus 6, which is 6. So I have 3 square root of 2 over 6. That is going to reduce to be 1/2 the 3 over 6 is. So this makes 1/2. So this is a square root of 2 over 2. So this one does exist because as you approach 3 from the left and 3 from the right, those limits are equal. So therefore, that does exist. So that one's not true. So then the limit as x approaches 3 is not equal to g of 3, which g of 3 is going to be 2 square root of 2. And as x approaches 3, it is square root of 2 over 3. Square root of 2 over 2. So that one is true. So that'd be A only. It'd just be 3 only, which is A. All right, so this one, I think these are a little challenging, maybe not, but these are the ones I find kind of challenging. It's just you're really tying a lot of things together with your calculus in this. So the function of f is defined above. What values of k, if any, is f continuous at x equals to 2? So we want the limit as x approaches 2 from the left of f of x to be equal to the limit as x approaches 2 from the right. We want that to happen, as well as we want that limit to be equal to, this is of f of x, to be equal to f of 2. So we want all those things to happen. Well, in order for that to happen, I want x squared minus 3x plus 9 to be equal to kx plus 1. Well, what is, kx plus 1? So x in this instance is going to be 2. So I have 2 squared minus 3 times 2 plus 9 is equal to k. I'm going to say 2k plus 1. And so then I'll just solve for k there. So I have 6 is equal to 2k divided by 2. And so k is equal to 3. So in order for k to be equal to 3, if k is equal to 3, then it would be continuous there. And then lastly, this one is challenging because you have you have x plus h, and so just simplifying that sometimes can take a little bit of time. So let's take a look at this. So the limit as h approaches 0, so I can't just plug in 0 for h here because then that would give me something over 0. So I'll have to do some simplification here. So I have f of x plus h is going to be 3 times x plus h squared plus 2 times x plus h minus f of x. So just leave it. So 3x squared plus 2x. And then that's all divided by h. So now I'll go ahead and square out and distribute my 2 and 3. Whew, okay, so that was pretty long. So I just want to make sure I subtract out what I need to. So my 3x squared subtract out, and then my, so this was supposed to be minus 2x. Excuse me about that. It's supposed to be a minus because that's a minus 3x. It's supposed to be minus all of that. So sorry about that. So then my x is divide out. Subtract out. So I'm going to be left with the limit as h, not x, h approaches 0 of 6x h plus 3h squared plus 2h all over h. Essentially, what you should get to at this point is that you can divide out the h. You should be able to have a common factor of h. So this h all divide out. And so I am left with 6x plus 3h plus 2. So h is, if I sub in 0 for h, this becomes 0. So I'm left with 6x plus 2. Boom. There we go. So that was one of the other ones I thought was kind of challenging because you have the x plus h. This also helps set up what we're going to do when we start looking at the derivatives. And that's it. Hope you have a good day and you'll take your test tomorrow.